Okay, so I'm not going to make this a very long video because I think I might have done this before actually. But essentially, one thing we want to know about. So, what is polygon? A polygon is just a two-dimensional shape. So, all these things are polygons. They're also regular polygons, which means that all the lengths of the sides are the same, and also the angles are the same. When we use the word angle here, we are obviously referring to the. So if I say angles in the shape, I mean this angle. Whoops. Let's try that again. I mean this angle. Oh my god. Why is it not letting me use the pen? Okay. This angle. Now we would call this the interior angle. I could have referred to that angle, and that would be not the interior angle. Actually, that's not really the best way to do it. The exterior angle is actually, if I were to extend the one of the sides like that, then the exterior angle would be this one here. Okay, so I can label that as I and that as E. Now, the rule is that the sum of the exterior angles of all shapes or polygons add up to 360 degrees. So in other words, and then so the sum, depending, if we say that n is the number of sides, then if I multiply n by E, which is the exterior angles, then that would give you the sum of the exterior angles. However, the exterior angles multiplied by how many there are, and that's going to add up to 360 degrees. And we also, so I did a bit of maths over here now. So rearranging that, we can see that E is going to be equal to 360 divided by how many sides there are. And we know that I is because it's on angles on a straight line, it's going to be equal to 180 degrees minus E, which we have an E is 360 divided by n, so I can sub that in. Then what I did is I factorized, so I put 180. Oh, and there we go. So we've got 180 multiplied by 1 minus 2 over n. So you might want to pause and just look at that in a bit more detail, see how I did that. And then I just did an example. Which was this example? Okay, so this was the example of the octagon. How to find out the interior angle of an octagon. So I didn't bother trying to find out the exterior angle. Well, we did start off with actually the exterior angle is going to be 360 divided by 8 because that's what n is, giving me 45. I is therefore going to be 180 minus 45, but you can just use this formula here. Sub all the values in, you still get the same answer. Now, so we did all that with all of these different shapes. Have a little play with it if you want as well. And I seem to have. I think I know what's happened here. This is because the software is being a bit annoying. Let's see if I can arrange it. There we go. That's where it used to be. So what this is, the reason why I drew this is clearly not a regular shape, but it does have 1, 2, 3, 4, 5 sides. So it is in fact a pentagon. It doesn't look much like this pentagon, but it is a pentagon because a pentagon is a shape with 5 sides. So this is a pentagon, and the thing to realize about that is that the sum of all these angles, the sum of the exterior angles will add up to 180 degrees. So the sum of the exterior angles will add up to 180 degrees, and so then from there you could work out what the interior angles are as well in each individual case. But so you can apply that rule. Oh yeah, so I was losing my thread a little bit, but if we go back to the pentagon, the regular pentagon, we worked out the interior angle was 108 degrees, and therefore the sum of the interior angles would be equal to 5 times 108 degrees, and that would be the same for an irregular pentagon. So the sum of an irregular pentagon is going to be the sum of the interior angles of an irregular pentagon would be equal to 108 degrees times 5, which is 540. And so if you knew some of these angles, you could work out the remaining ones. So that's kind of what you've got to do on some of these questions here. But I won't have time to go over that at the moment, unfortunately, so I shall stop the video there.